Alright, so in this video we're going to dive into the next major concept for the AP Computer Science exam. And that's going to be looking at these things called data structures. And we've sort of been alluding to this entire time. Whenever you would have like a name or a number or maybe some sort of a choice or whatever. The example I can really think of is like the monsters, the movies, the songs. You would have to keep making these things to be like movie 1, movie 2, movie 3, movie 4, so on and so forth. And the same thing when we were talking about the students in the school. So a school could have as many students, as many kids as you could fit in it, right? But in order for us to model that with what we know, you would have to just keep numbering them. For example, let's say you had something like, let's see, string my favorite, oh, let's just call it, we'll call it video game. Mario Kart. Okay, so now we've got a string, and it's called video game, and it's Mario Kart. Now, let's say we wanted to represent our entire video game collection. Well, now we have to do something kind of like this, and it's going to get ugly. We've got Tetris. So you got Minecraft. So you got Fortnite. See, what else is popular? I don't know. Plenty of those to go around. Okay. So, you can see the problem here. This list could just keep getting longer and longer and longer and longer. And in your program, you're going to have all these variables that are almost identical. So it's going to get kind of confusing. Imagine you were way down here. You'd written bunches and bunches of code. And you're trying to get all of these. For example, let's say you wanted to print them all. We'll just print each one on a line, right? Oops. So that's not that bad. I mean, I can just take this line, copy it. Oops. And paste it a few times. But then if I want to add another game, I'm going to have to also add another print statement. Let's save this. Pilot. And it does run. There's nothing wrong with it. But this is pretty ugly. And like I said, it's kind of hard to maintain if you want to keep adding them. Plus, how am I supposed to remember which one is which? But this is terrible. So wouldn't it be nice if there was actually a way for us to represent this a little bit cleaner? And in fact, Java and pretty much all programming languages, or at least the object-oriented variety, are going to have these things called data structures that will let you represent this in a way that's a lot cleaner and will let you actually use and interact with this data easier. So what we're going to look at in this video is something called an array. An array is like one of the most basic of the data structures. In fact, I think you're going to get this pretty quick because an array is a lot like a string. If you remember when we looked at the string class, we'll just look at Mario Kart for a second. Oops. So remember, the string is actually made up of a bunch of characters. So the string is a data type, but it's also a data structure. It's what we might call like a simple data structure. So you got the M, A, R, all the way down to the T, right? And each of these letters, each of these characters, is at an index position, starting at 0, counting up to the length -1. Well, we can actually make a thing that's sort of like a generalized form of that. So if I wanted to store all of these into one thing, one data structure, and I didn't want to have to make a class for it, because you'd also run into the same problem there. you would have to save all these variables inside the class, right? Like what we did with that the pair of dice program, just had 2 dice inside of it. The easy way to fix this is we know that the data type is going to be a string, and you put these square brackets here after it. And you can think about that kind of like a box. It looks like a box, right? The square bracket, the other square bracket. You're telling Java, give me a box that I can put all these strings in. A string box. Then you got to give it a name. Call it video games because it's plural. Equals. And then what you can do is use these curly braces. Put the semicolon. And you can just put everything that you want to put in the box inside the curly braces. So what I'm going to do is organize it a little bit like this. You don't have to put these new lines in. You can do this all in one line. My font's just a little big for that. Or you could have some on one line and some on another line. That's really up to you. But I'm going to do this just to show you that we've got a list of things. Okay. So now we've got this, what you call an array of video games. And it holds all of these. Let's compile it, make sure there's no errors. There's a warning, because we're not ever using this. And we run it, and it still does what it's supposed to do. So the word array, don't let that scare you. It's kind of just like how you would use it in English if you were to say, well, there's a wide array of things. So an array is sort of like a list. So this one thing, this one variable called video games, holds all of these. So we didn't have to number them. So let's take a look at how you would actually use this thing. So let's say you wanted to get Mario Kart, I guess. Or let's go for Minecraft, the one in the middle. So let's do system.out.println. And this is actually really easy. It's even easier to get Minecraft out of there than it is to get part of a string out. Because remember, with the strings, you had to do all that substring stuff, and it could get confusing. But with this, you just do video games. You put the little square brackets, because we're talking about the box. So this box here. And I want the thing that's at position 0, 1, 2. So get me the second thing in the box called video games. And print it out. Compile it. Run it. And there it is. You see we grabbed Minecraft out of that box. And what if I wanted to get the thing at position 1? So Tetris. Save it. Compile it. Run it. There it is. We got Tetris. So maybe you got some light bulbs going off. You know, the alarms are blaring, and you're like, hold on a second, I see what we can do here. See, this giant block of text, we can actually get rid of now. We don't need it. I'm actually going to delete this too. So what if instead of doing that, well, hold on, let me bring that back for just a second so you can see it. So you see, there's sort of like an off by one thing here. If this were to be video game 0, 1, 2, 3, 4, these would match with the index positions from in here. So all this is a way of holding these all together so that we don't have to worry about, if we do it this way, the computer doesn't know that they're connected. It doesn't know that they're all actually part of this bigger video game collection. That's just us figuring that out in our head because of what we called it. For all the computer knows, these are completely different things. But this up here says, all right, all these things go together. Package them up in a box for me so that you don't lose them. Okay, and then this is how you'd print them. So actually, I'm just going to comment this out instead of deleting it so that we can come back to it. Edit, comment lines. So it looks like we're doing something over and over and over again here, right? The only difference is the number of the video game. And what should you think when you hear that we're doing something over and over and over again? Well, that sounds like it's a loop to me. So we can use a for loop. Let's make a variable called I, started at 0, and how far do you think we're going to want to go? So we're going to keep going while I is less than, let's see, we want to go through all of these, so let's do video games, and then you can do something called dot length. And do not put parentheses at the end of this, because dot length is actually a variable that exists inside of this array. And it tells you not necessarily how many things are inside of it, but how big the box is. It's sort of like in real life. You can have a box that's not all the way full. So the length is going to tell you how many things you could put in the box. So in this case, we made the box and we filled it up. There's no empty spaces here. So the length will be 5. And then every time we're going to update I, we're going to add 1 to it. So we'll just grab this, put this in there, and there we go. So instead of grabbing a specific position, we had 1 in there just a second ago, we're going to grab I. So we'll grab 0, then we'll grab 1, then we'll grab 2, then we'll grab 3, then we'll grab 4, and then finally, well, yeah, 4 will be the end of it. Alright, so let's compile it. No errors, that's good. And we run it, and we see that it has the exact same behavior that this had. But this is significantly shorter. So we don't have to worry about all of these print statements anymore. And we don't have to worry about keeping track of all those variables and keeping them together. So in fact, to show you this actually can be even shorter, I'm going to put these, actually I can put Minecraft on this line, I think. Yeah, that's okay. As long as the reader can still make sense of it. And we'll run it. There we go. See, Mario Kart, Tetris, Minecraft, Fortnite, Call of Duty. Yeah, you see how much shorter this is? So we made a box, called it video games, we put in all of our video games, and then we printed them out. Alright. Okay, so the best way, I think, to learn this, and to really grasp it, is just to go through some more examples. So we did video games. Let's look at something like maybe, let's say, a restaurant menu, okay? So I'm going to delete this, and we're just going to start over. And there we go. Okay, so just in comments this time, we're going to say that we got a restaurant, and this is their menu. So they have pizza, cheese, oops, burgers, we'll make it all singular though, fries, hot dogs, let's see, what else are they gonna have? Chicken sandwich. Should probably have nuggets. They're also gonna have ice cream. And maybe something healthy. Like a salad. Okay. So we got 8 things that are on the menu of our fictional restaurant. So, take a moment, and you can rewind this video and go back to the previous example if you want, and think about how you might add all of these things to an array. Okay. So, hopefully you took a moment, maybe paused the video, and you thought about that. Let's take a look at how you can do it. So, these are strings, and we're going to want to make an array out of them. So, a box of strings, we'll just call it the menu, and curly braces, just like before. Then we just throw all the stuff in. Cheeseburger, one word? I think it is. Oh, we said singular, didn't we? Okay, there we go. So I'm going to go and delete this because now we've moved everything into this menu. And let's print everything out so that we can see that it's in there. Or actually first, let's just do system.out.println. And let's print the length of the menu. And just for good measure, let's print the last item in there. So what we're going to do is menu. And this is what we call indexing. So we need the index. We'll do menu.length -1. So we should get 1, 2, 3, 4, 5, 6, 7, 8, and then salad. Let's see if it works. 8, salad. Nice. So let's print them all out. So for int I, started at 0. I guess we'll do that. Menu.length. So while I is less than the length, increment I, and on each loop through, just print out the item. Beautiful. So there we go. Alright, so that's 2 examples of how you might do this. And now, let's actually take a look at something that we did before. Something that I think I might have even alluded to when we were working on it. I want to go back to this monster example. And you see right here, if you make a monster, but you don't provide it with a name or a type or anything, it randomly picks the name and the type. And we really didn't know how to do any sort of good comprehensive randomness before because we didn't know how to make this list. So really, we would have to keep adding these if statements to be like, well, if it was less than 0.1, do this. If it was between 0.1 and 0.2, do that. And so on and so forth. And as you can imagine, that would be really big and really ugly, and it really wasn't worth our time because that really wasn't what we were trying to do. But now that we know how to make these arrays, what we can do is come up here to the top. I'm just going to make a private variable. I'm going to call it names. And we're going to say it's an array by putting these square brackets at the end of it. And we're going to make an array of names. So let's see, we've got Dracula down there. And we've got Bob, so we don't want to lose those. But we also I remember had something called Dreculi that we used. And now I'm just going to throw in a bunch of random names. Put in as many as we want, really. Hank, Bill, Brian, Sam, oops. Okay, there we go. So we got a bunch of random names, and now let's get some monster types. We call them types. And let's see, we got vampire, we got mummy, I believe we also had a yeti, but now we can add some more. Let's do a werewolf, a zombie, let's see, what else we got, I don't know, a goblin, troll, and let's see, one more. Sort of lame, let's just do a gnome. Okay, so you see these aren't even the same size. They don't have to be. They don't have to match one-to-one, because the names and the types are two separate things. Down here, they sort of went together. All Dracula, or all vampires were Dracula, all mummies were Bob. So I'm gonna get rid of this. Don't need it anymore. And what we're going to do is grab that randomness from before, so math.random, just like we were doing when we talked about the integers, the doubles, you know, the math class. And how many things do we want? Well, we want the length of names. Right? So however many things are in there, that's how many numbers we want. 0 up to that one, but not including it. Right? So that's going to give us that index position. And in theory, you have a +0 there, but we want to start at 0, so we're not going to worry about it. Now, you're going to say this dot name is going to equal names at whatever index we grabbed. Right? It's just like this. This dot name equals the name that we gave it, but in this case, the name is going to equal whatever random name we've picked. And let's give the monster a type. I'm just going to copy this because it's the same. Except for we want to change name to type, names to types, types. That was pretty cool, right? We got a duplicate local variable. We might want to deal with that. But yeah, let's do that. Okay. You could clean this up even more, but this is just a quick little example to show you the power of what we've just learned. So, if you recall, get a random number between 0 and 1, not including 1. Multiply that by how many numbers you want, which is the length. So now we've got a number between 0 and the length minus 1. So we can get every index position in here randomly. And then we grab the name at that random position. So let's actually try this. Let's compile it. Ooh, we've got ourselves an error. Let's see. Oh, my bad. That's the name of the thing. So it goes there. The type of it is string. Okay, there we go. That made it happy. Yeah, my bad. Okay, so let's see if we can interact with it. So let's just try to make a monster first. We'll call him Harold. Harold is going to be a ghost. He's going to be not all that scary. Maybe he's like Casper the Friendly Ghost. Name monster not defined. Let's see, monster M equals new monster. Harold Ghost. Alright, there we go. So his name is Harold. M.getType ghost. So now let's make another monster. Call it M2 equals new monster. And this time we're not going to specify any of the stuff. So we're using this default constructor that's doing all the randomness that we just programmed. M2.getName. So her name is Sarah. And Sarah is a vampire. But we can do it again. So now this monster's name is Tom. And Tom is a werewolf. And just to prove to you that this is random, let's do it again. So you could get the same one twice, but the odds of that aren't very high, because we have so many options. Alright, what is monster number 4? Oops. His name is Brian. Kinda hope he's a zombie. Oh, he is a zombie. Brian the zombie. You know, just flip the I and the A and he becomes Brain. Alright, I'm happy that that's how that worked out. Okay. So, there you go. That's how you can use randomness to greatly increase your projects, your assignments. Okay. So, one more thing. And then I think this video's gone on long enough. But let's look at something called an enhanced for loop. So let's say you wanted to print all of these out, but you didn't want to have to do all of this, right? You didn't want to have to do the index positions, because we're not really using I for anything. We're not doing any sort of math with it. The only thing we're doing is using it to grab the position. So wouldn't it be nice if we could just go through this and not have to worry about the indices at all? That would be sweet. And it turns out you can. So let's do string food menu. And I'll talk about all that in just a second. And we run it, and it prints out the exact same. So this is what we call a for each loop. It's sort of like the enhanced for loop for an array. This also works with other data types, other collections, where it lets you just go through item by item so you don't have to worry about the specific indexes or where stuff is located. So it's just like the original for loop, the one that we learned weeks back. We have to create some variable. And in this case, we know that this array is full of strings. So it's going to be string, we give it a name, I called it food, you could have called it M, you could have called it item, you could have called it whatever you want, doesn't matter. But I called it food. And then this little colon just means in. It just literally is like in. For the food in the menu. So for the food of type string in the array menu, this is what I want you to do. Go through and print the food. So this is a lot shorter, it's a whole lot easier to read too, once you know what the colon means. And with that, I think I'm going to end this video. In the next one, we'll look at some more examples. I've got an example where we're going to look at, well, I'll just save it for the next video. If you have any questions, let me know. Hopefully this made sense, and I think it will make even more sense as we keep practicing it. Alright, well, I'll see you in the next video.